Let us start today's class. Power loss. What are the corona power loss? When corona occurs in a system, power is dissipated in the form of heat and light, and it is known as corona loss. It is very difficult to calculate corona loss accurately because of its extremely variable nature. A number of empirical formulae have been developed by various scientists to find the power loss due to corona, which are applicable under fair weather conditions. That and all they have already estimated and found it. To estimate the losses under bad weather conditions, arbitrary annual loss factors are applied. It has been found that the corona power loss under fair weather conditions is very small and negligible as compared with that of bad weather conditions. According to Peak, the corona power loss for a single phase or unsymmetrical three-phase line under fair weather conditions is given by PC is equal to, the formula is given to 42.2 F plus 225 by del. Yeah, this is actually, though it is displayed in the screen, where P stands for power corona loss, F stands for frequency of the supply, del air density factor, En RMS voltage, that is here V, which is nothing but off into voltage between lines for single phase line. Under bad weather conditions, it's given, the another formula will be given. Using that another formula, that's especially here, F plus 25 by del, but it is 244 En minus 0.8 E naught square into root of r by d into 10 raised to minus 5 kilowatt per phase per kilometer. Next, coming to radio interference due to corona. The corona discharge emits radiation which may introduce noise signals in communication lines, radio, and television receivers in this vicinity. This is called radio interference. Or this radio interference from overhead lines is caused by corona on conductors and fittings, surface discharges on insulators, and poor contacts in fittings and insulator strings. This radio interference is predominant only due to corona discharges in AHV lines. According to Trickle, the corona discharge from a negative point contains fast and regular pulses whose frequency increases with the increase in voltage. A corona discharge which builds up and extinguishes itself in a short period of time of the order of a fraction of a microsecond is called a corona pulse. These pulses from a negative source are known as trickle pulses. Corona pulses are also produced due to a positive source. Trickle pulses are of two forms. One is burst pulse, another one is streamer pulses. This radio interference is mainly due to the presence of these pulses in the corona discharge. The streamer type pulses produces radio interference much more than the negative off cycle radio interference. When the field intensity is less than the critical value, the interference is mainly due to negative off cycle pulses. But above the critical value, RI is due to positive off cycle pulses only. RI increases more rapidly than corona loss due to increase in the voltage. It is also very much influenced by weather conditions. Extremely bad weather conditions may increase RI as much as 20 times. While designing HV and EHV transmission lines, care must be taken to see that RI and copper losses, corona loss levels are kept under tolerable limits. What are the methods of reducing corona effect? By increasing the conductor, that spacing between the conductors, as well as by increasing the diameter of the conductors. We know that already we understood that how disruptive critical voltage is given by, okay, by E naught is equal to M naught del G naught R into ln D by R. So by increasing the spacing D between the conductors, the disruptive critical voltage may increase. For increasing the spacing between the conductors, the sizes of the transmission towers has to be increased, which is uneconomical. Hence, this method is not normally resorted to decrease corona discharge. Next one is by increasing the diameter, means size of the conductor. Here we find that the disruptive critical voltage can be increased by increasing the diameter of the conductor, but this method has been found to be very effective in reducing corona loss. The diameter of the conductors may be increased by using either hollow conductors or ACSR conductors. Bundled conductors are used extensively on EHV and UHV transmission lines to reduce corona loss. The bundled conductors act as conductors of large diameter as compared to their component conductors. This reduces the voltage gradient and hence higher voltages can be used for permissible levels of RI. The reactance of a bundled conductor is low and hence increases the transient stability of the system. So this is about today's class.